Baking is an essential skill here at ATP Electronics Factory. We have ovens that serve all sorts of purposes, except for cakes and pastries, of course. And we are passionate about burning our products. Hi, I'm Jerry Wang. I will introduce you to a special process we perform at ATP to make sure that only the best quality modules with the best quality components reach our customers. Have you heard of TDBI? In this video, I will give you an exclusive peek at our purpose-built factory to find out what it is. But first, let's take a look at its different modules. They all look the same, right? You will have no way to determine their reliability, endurance, or performance. Many customers will judge based on brand, others on published specs. Choosing the right gear module is a crucial decision, especially for mission-critical embedded and enterprise applications, where you can afford to disrupt operation just because a memory module breaks down. You see, ICs within a wafer may not all have the same quality. They may be strong and weak ICs in one wafer. When different quality ICs are used on the same DRAM module, the module will cause unstable system operation. Even just 0.01% error on a 99.99% effective device can increase the failure rates at the module level and lead to failure during actual use. Repeat, a mere 0.01% error. That seems like a small, insignificant number, but imagine large-scale implementation of hundreds of even thousands of modules. 0.01% can translate to a big impact in terms of DPPM. It can potentially cause massive trouble. ATP wants to eliminate the 0.01% error to make sure our DRAM module only contains the most robust ICs for maximum reliability. This is why we perform TDBI. As its name implies, TDBI involves subjecting module to various temperature, power cycling, voltage, and other stress conditions within a certain period. The burn-in process causes weak ICs to fail. We screen those out, making sure that only the most robust module meet customers' requirements for their applications. Other module manufacturers also do TDBI, but they install the modules on testing systems, put them in big ovens, and thermally stress the whole system. Let us compare the typical motherboard-based TDBI with ATP's unique TDBI system. In terms of testing duration, in the typical TDBI, motherboards must stay in the chamber for days. ATP's TDBI using the mini chamber requires only a very small fraction of that time. When it comes to the reliability, in the typical TDBI, the motherboard and other components are thermally stressed. This could lead to the failure of non-DRAM components and thus cause a false fail. Replacing these damaged components adds to the cost of the testing. In ATP's TDBI, temperature cycling is isolated only to the module being tested, so as not to thermally stress the rest of the testing system. This minimizes the failure of non-DRAM components. Depending on customers' requests and application-specified needs, ATP can also perform customized testing according to different parameters, such as temperature, loading, speed, and time. ATP's TDBI system takes a lot of time than typical motherboard-based TDBI, and avoid any potential costs brought by false failures, component failure during burn-in, and potential in-field failures. All this translates to best TCO value with higher accuracy and better production efficiency. ATP's TDBI system, we can detect and screen out up to 0.01% error to significantly lower failure rate and extend the product service life. Through TDBI, we have drastically reduced DPPM in the hundreds, whereas the sellable DPPM rate in the industrial is 3,500. Isn't that great news? With reliability guaranteed, this module performs better and longer. In an enterprise with hundreds or thousands of systems running constantly, with each one having multiple memory modules, consider the impact of this test on your TCO and the return on investment. Next time you visit a bakery, I hope it reminds you why we burn this module to screen out the weak, so you can get only the best. Thanks for watching. I hope you learned something new from this video. If you like what you saw, please subscribe to the channel. See you next time.